Welcome to Beacon High School online video. Today we are going to learn about measurement and motion. How did people travel in olden times? In olden days, people used to travel on foot or on the back of the animals. Thus, they used to travel for days to reach even the nearest town. They had no watch to tell the time or milepost to tell them the distance they had traveled. They used to observe the sun and keep a track of the time. With the invention of wheels, things became easy. Animals were used to pull vehicles on wheels. Then came steam engine followed by diesel and petrol engines. Now we have electric trains, metro trains, monorails, aeroplanes, spacecraft. And we have various instruments to measure the distance and time. We use watch to measure the time. At school, we use scale to measure the length of a line, and vegetable vendors use a balance or weighing scale to measure the weight of the vegetables. And when we have a fever, we use thermometer to measure the body temperature. History of measurement. In olden times, the length was measured using non-standard units like foot span, hand span, arm length or cubit. This technique does not give the proper measurement. So, there was a need for standard unit. We need standard unit to measure any quantity so that everyone gets the same answer when measurement is done. When we measure anything, we compare an unknown quantity with the known quantity, and that known quantity is called the unit. So, a unit which has always the same measure is called standard unit. The French in 1790 created a standard unit of measurement called metric system. So, scientists from all over the world today have adopted a set of standard units of measurement known as International System of Unit, which is abbreviated as SI, from the French system internationally units. For everyday life, we usually measure four physical quantities: length, mass, time and temperature, and these are called fundamental quantities. Let us study different physical quantities and their units. Length. Length is the measurement of distance between two points, and its units are centimeter, meter and kilometer. Centimeter is used to measure the smaller quantity and kilometer is used to measure the larger units. Centimeter is written as small letter cm, meter small letter m, kilometer small letter km, and its SI unit is meter. Now mass. Mass is the weight of the body. It is the quantity of material content of body. Its units are gram and kilogram. Gram is written as small g. Kilogram is written as small letter kg and its SI unit is kg. Now time. Time is the measurement of a moment. Its units are second, minute and hour. Second is written as small s, minute is written as min in small letter, hour is written in small letter h, and its SI unit is second. Now temperature. Temperature is hotness or coldness of an object. Its units are Celsius, Fahrenheit, Kelvin. These three are written in capital letter. Like for Celsius, we write degree Celsius, Fahrenheit, we write degree F, Kelvin, K. And the SI unit is K. Following points must be remembered while writing down the unit of any physical quantity. First, the names of units are generally written in small letters, even if they come from names of scientists. For example, meter, Kelvin, centimeter, except Celsius and Fahrenheit. Next, symbols of units are written in small letters unless they are named after scientists. Symbols for units are never written in plural, but when written in words, plural is used. For example, length of pencil is 10 centimeter. So here we will not put S after cm. And when we are writing them in the words like 10 centimeters, we can put S after the word centimeters. Now, symbol of a unit is not followed by full stop unless it comes at the end of the sentence. Units for volume are liters and milliliter, so they are written as capital L and small letter m and capital L in short form because they are derived quantity. Measuring length. We can measure the length of the straight line using a ruler or a scale. But to measure the length of a curved line, we need thread and a ruler. Take a thread and tie a knot near one end of the thread and place it on the curved line from where it starts, and then put it an ink mark on the thread where the curved line ends. Now hold the thread and place it on the straight ruler and then read the scale at the point where there is an ink mark. This will be the length of the curved line. Motion. When you observe things around, you will find that certain things change their position with time, while certain other things do not change their position. For example, table, chairs, they do not change their position on their own. We say they do not move. These objects are at rest. But a person, when he is walking, a moving car, a moving train, flying bird, they change their position with respect to the surroundings. We say they are moving, they are in motion. So, when an object changes its position or direction with respect to the surrounding, then the object is said to be in motion. And you know that motion and rest, they are relative. For example, all the things inside a moving train are at rest with respect to the inside of the train, but they are in motion with respect to everything outside the train. Let us study different types of motion. First is translatory motion. Translatory motion means when whole body part moves uniformly in a straight direction. It is of two types, rectilinear motion and curvilinear motion. When a body moves along a straight line, it is called rectilinear motion. For example, motion of a car on a straight road, a ball rolling on the flat ground, an apple falling from a tree, water flowing from a tap. Curvilinear motion. When a body moves along a curved path, its motion is called curvilinear. For example, a train taking a curved path in hill station, a dolphin taking a dive, a ball coming down after being thrown up at an angle. Next motion is oscillatory motion. A motion in which an object moves to and fro about a central or mean position is called an oscillatory motion. For example, when you sit on a swing and after you push the swing backward with your foot once, you come back and go forward. This backward and forward movement is called to and fro. Other example of oscillatory motion is your swinging motion of your hands while running. Next is vibration. Vibration motion is also an oscillatory motion where an object moves to and fro. A string of guitar vibrates when plucked, vocal cord vibrates when we speak, and our eardrums vibrates when a sound reaches it. Next motion is circular motion. Just observe a fan. It is fixed at one point and it follows the circular path. So, a motion in which all points of an object move around a fixed central point is called circular motion. For example, wheels of moving vehicle, merry-go-round, spinning top, Earth's movement on its axis. These are examples of circular motion. Next is periodic motion. A motion which repeats itself after a fixed interval of time is said to be periodic. For example, motion of the hands of a clock and to and fro motion of pendulum, earth revolution around the sun is example of periodic motion. Next motion is random motion. In such motion, there is no fixed type of movement in the moving object. For example, observe an ant or a moving butterfly. They follow all the combination of the motion. So that type of motion is called random motion. Different motions at the same time. In our daily life, you have observed that objects, they show different types of motion simultaneously. For example, a moving bicycle which moves straight on the road displays rectilinear motion or translatory motion. But at the same time, the wheels of the bicycle which are moving in a circles display rotational motion or circular motion. So, wheels of moving bicycle displays both rectilinear as well as circular motion. Now next, in a sewing machine, the needle is in periodic motion, whereas the wheels of the sewing machine are in circular motion. So, wheels of a sewing machine displays circular and periodic motion. So, today we have learnt all about the different physical quantities and their units, about the motion and different types of motion.